Hello, everyone. My name is Christopher Adams. In lieu of an introduction, you can just find me on GitHub. I think that should link to everything.
Thank you. I'm just kidding. No, go ahead.
I'm super thrilled to be here today. This is actually my first RubyConf, because now it's RubyElixir Conference. I wanted to thank the organizers, first of all, for making this happen. It's kind of a small Elixir community here, just getting started. We do have a meetup every month. It's the first Monday
First Monday
of the month. So if you're based here, I'd encourage you to please come join our little family. I'm actually going to try to do 2 talks today. So, why do 1 talk when you can do 2 in like the same amount of time? So I want to talk a little bit about style and programming styles, and then apply that to some web stuff in Elixir. Style, I think, is about making choices. I'm not going to justify this quote, you just have to accept it. So one choice that I faced, looking back at my education, in the introductory computer science course in my university, we were given a choice. There were 2 different tracks, 2 different classes. One class was in Java, and then the other was in Scheme. And I'm like, what is Scheme? If you've heard of it. So this is the choice I had to make. On the Java side, we have a language that is imperative, meaning basically you have to tell the program, tell the computer what you want. It's static, it's compiled, it's object-oriented, kind of a commercial system, based on C and C++, and it looks something like this. Scheme, on the other hand, has anybody ever actually heard of this? Scheme? All right, a few people. All right, the smart people are in the back of the room. The smart people should be in the front of the room. Come on, guys. So Scheme is basically the opposite of most of these. It's a functional language. It's dynamic. It's interpreted, sort of like some other languages we might know, like Ruby. Instead of being object-oriented, it uses S expressions, which are basically just programming with lists. Rather than being a commercial language, it's really more academic, and it's based on Lisp, or very similar to Lisp, and it kind of looks like this. So for some reason, I chose the Scheme class, which was smaller, and it just seemed like, okay, I want to do something different. I want to make a choice. I don't want to do, be in the big lecture hall with the Java guys. I want to be in the small room with the Scheme and functional programming guys. I think this is probably the reason I'm using Elixir today, because I made this choice to do Scheme. Otherwise, I probably would have missed the whole functional language idea. Maybe I wouldn't have learned it in university. So if this is the Java Scheme, I kind of wonder about RubyElixir. Like, what is the choice here? I think a lot of people who come to this conference and maybe are either using Ruby and then have kind of heard of Elixir, maybe are thinking, is there a similar kind of choice here? So if we made the Java and Scheme, like what goes on each side of you? What would be on the Ruby side? And what would be on the Elixir side? Anybody? So I think this is actually kind of a false choice. I really think there's only one thing on both sides. So for me, it's I could use both, but I choose to use Elixir. So my path to Elixir was basically when pre-version 1 is when I heard about it. Oh, there's this cool new language called Elixir, and I looked at it. And I just was not adventurous enough to use pre-release software. So I learned Erlang instead. Go back. And then once Elixir became version 1.0, I really started to get into it. I eventually became the maintainer of an Elixir style guide, and I'm going to tell you a little bit about these. So there's basically 3 style guides. for Elixir, which is actually pretty manageable. If you look at Ruby or Node, there's probably dozens. So I can cover all these in like 2 minutes. So you can find all these projects on GitHub. This is the one I maintain. It started in 2013, although I did not start the project. I can't claim to have the foresight in 2013 to start this. But the original version of the Elixir style guide was basically copied from one of the Ruby style guides. I just, changed a little thing, syntax here and there. That was enough to get it started. It has about 40 contributors, about 250 commits, and about 1,300 lines. And we tag it as a community-driven style guide. I started out as a contributor and then was asked to become the maintainer, which I am doing to this day, although as you see, it's getting a little more tricky with Elixir 1.6. The second one is by the developer of Credo, which is sort of an analysis tool for code quality. Started in 2015, 7 contributors, only 25 commits, and about 700 lines of code. And if you use the Credo tool to analyze your code, this is the style guide that's kind of based off it. The last one is Elixir style guide, now with hyphens. It's like a choice. There's your style, underscore, hyphen, whatever. Also started in 2015. This one is maintained by some core Elixir members. So Jose kind of said there's no official Elixir style guide, but if there were one, it'd probably be this one. It only has 900 lines of code, and only 8 contributors. I don't think any of the style guides have rules that violate the others, so you should be good with any of them. With Elixir 1.6, the whole style question is kind of thrown up in the air, because now there's a format. So instead of reading the whole style guide, you can just install Elixir 1.6, type mix help format to figure out how to use it, and then mix format your code. And then there's a config file, the .formatter file, and that's kind of it. I'm going to come back to the end about the questions this poses for a style guide and what we could possibly do in the future. But I kind of want to turn to style not in the code formatting sense, but in the architectural sense or design of program sense. So let's kind of look at some domain-specific language styles. When we're doing programming, especially with macros, we often look at a DSL as the way we design our software. So let's look at these two designs and compare them. So on the left is SINATRA. It's a Ruby web framework. And on the right is Plug, if you can read it. So SINATRA has a get hello. Oh, I don't know. There's a syntax there in the Ruby. Can you guys spot it? This is not intentional. Come on, Ruby people, what's the error? The do, there's no do there, right? There shouldn't be, right? Or is there? Alright, I'm going to betray. I'm not a Ruby program at all. What we can see here, though, is even though there's a little bit different between just returning the string in the SINATRA app and the plug is calling a function, basically the DSL is the same. It's the same style for writing a web application. We have a verb, HTTP verb get. We have the path. We have a do, maybe, maybe not. Somebody please check this. I can fix the slide. Then we have the response. And that's the DSL. So if we say, the style of a SINATRA app in Ruby and the architectural style of the plug app, at least from a programmer perspective, is the same, more or less. If we look at another web application, Rails and Phoenix, it's kind of the same story. So we have in each case, a router, right, and then some kind of controller. So in Rails, we have the get pages, and we dispatch to this controller and a method. And in Phoenix, we have the same kind of DSL. We have the verb, the route, and then where we dispatch to. And then when we open up the controller, we also get this exact same style. We have the method, in the case of Rails, index, we render the index. And in Phoenix, it's basically the same thing, except we have, our inputs to the function. So I would again say that these two, even though they're different programming languages, different frameworks, they have the same architectural style from a usability perspective. But I don't think we should be limited just to these styles. I think we can try to expand our minds a little bit. So maybe you've heard Chris McCord's Phoenix is not, what's the end of the sentence? No. So Phoenix is not your app. And that's sort of in contrast, I think, to Rails, making the point that Phoenix is just a component of your application, not the whole thing. Well, I'm going to make a kind of bigger claim. I'm going to say that Phoenix is not MVC, which is the model view controller pattern that we're basically used to from Rails, and we saw in the previous slide. We have our router controller going to a view, and then maybe there's a model in there somewhere. So can I prove this? If we peel back Phoenix, kind of peel back the layers, what we find is plug again. And this is basically the plug specification for writing any component that can plug in into your web application. We have an init function, which just takes options and then can return the options with some changes if necessary. And then a call function, which takes the connection and some options and then returns a response. Actually, what it returns is another connection. So here there's no model, right? There's no view, really. There's no separate view. And I guess you could consider this as a controller, right? You do dispatch. So this means if you pull the layers of Phoenix back, this is what you get at the end. And what this allows you to do is to write web applications in other styles that are not just the MVC as we see in Rails. So let me show you an example of like a not MVC. Don't be scared, there's some airline on the next slide. All right, so this is an application called Web Machine. Kind of like we see in Phoenix, there is this concept of a router that's basically dispatching. The difference here is that the dispatch is not based on the HTTP verb. So if you're doing Rails, right, it's like each thing in your router is get this, post this, and it's going to dispatch to a different function. Web Machine takes the view that your dispatch is to a resource in the REST sense. So you're not dispatching to a function, you're dispatching to a module. That module will then implement functions as callbacks that define your resource in a declarative way, more functional stuff. So this is a very simple example of a web machine in Erlang. It has an init function, and then it tells which content types it provides. In this case, we're just going to say, if we get a request for text HTML, then we're going to dispatch to this toHTML function. If we wanted to add JSON to our API through content negotiation, all we have to do is add under the HTML, let's define the JSON, application JSON, and then we'll define a function that we dispatch to. Web Machine defines a number of callbacks to declaratively describe your resource for things like basic authentication, content negotiation, etc. HTML right at the end. So this is actually possible to do in Elixir and with Plug. I know because I've done it. And it's a different way of thinking about your application design, your web application design. So if you're a Rails person or a Phoenix person, I highly encourage you to, at least once in your life, try one of these applications. These are all web machine inspired, but written in different languages. So there's web machine in Airline, Cowboy, which is the web server that underlies Phoenix, actually does have a REST handler that you can plug in. It kind of works in the same way, giving you that declarative approach to your resource design. Elixir has eWeb Machine, which is kind of was a direct port, but now it's been rewritten. And then FLICKREX is one that I wrote kind of as an experiment. If you're a Ruby person, you can try Web Machine Ruby, which is a pretty faithful port from the original Airline version. Haskell has Airship, Clojure has Liberator, F# has Freya, and this is not even a complete list of all of these. This is the slide we should take a picture of. So in working with these and working with Elixir, I kind of went back to this functional idea of programming for the web. So I mentioned the spec for plug. We just basically have two functions, the init function and then the call function. And you might have seen the input to the call function is something called the con or the connection. And this is what it looks like. It's actually a data structure. And this is basically, I was amazed I fit this on one slide. I don't have to cut something off. Kind of unlike Rails, although I'm not a Rails person, so you can correct me. With Elixir and with Plug, each, let's say, controller action is taking the connection as the input. It's changing that data structure, and then it's returning it back to whatever's calling it, the plug that's calling it. So here we have basically everything you need to functionally describe what a request response looks like. Everything from body parameters, the cookies, the method that's being called, the path parameters, the query parameters. And then we have a way to change things like the response body, response cookies, etc. So it's functional, it's input output. Whatever's going to come into the function, this is what's going to go out. So this design in Plug, I think, is actually applicable to a lot of other functional designs in web programming. So what else could we do? If we think about the request response cycle being, functional rather than just something that we do imperatively. So one idea that I've implemented, and this kind of came from a great library called XAWS, which is an AWS client in Elixir. I went through this process of kind of thinking imperatively or thinking traditionally and then thinking functionally about designing, in this case, a web client instead of a web server. So here's kind of the before and after. Almost every web client, like I want a GitHub client, I want an AWS client for any language, whether it's Ruby, Node, kind of looks like the before line here. I'm just going to tell it like what I want it to do, and it's just going to do it, like in one action, right? Behind here somewhere is going to be a whole stack of things that happen. Usually there's going to be an HTTP client somewhere in there. And that's it. Like, really, every client kind of looks like this. But I was inspired by XAWS to find a different way to do this. And this is what I think is a more functional approach. So back to data structures like plug-con. In this case, what we're doing is our first step is to create a data structure that describes the action that we want to take in a functional way, kind of like the plug connection. So in this case, it's a Flickr library, and we want to get the recent photos. So the first step is taking um, Flickr photos get recent, and what that returns is a data structure. The data structure has the things like the default parameters, the format, if we want JSON or XML. It gives us the HTTP method. It gives us the kind of method argument to the Flickr API, some params that we want, and then it gives a function that's going to parse the response. After that, it has the path in the API, like what is the slash whatever slash services rest, and then the service that we can use, and that will get our configuration. We then take this data structure, and once we have it, then we can, oh, there's a typo, then we can pass it to a request operation. So what's the advantage of this? Basically splitting this up into two parts. Well, kind of like our plug connection, the advantage here is that once we get, we call our get recent, we have a data structure that we can manipulate. For example, maybe I want to change some configuration about it. Maybe I want to add some extra parameters. Maybe I have a function that can take that data structure and add another query onto it. Maybe if I'm using something like GenStage, and I have a bunch of these that I want to process, it's possible to have one function that will create all the operations that I want, and then another function that will actually do the request. And that allows you to split up the declarative part, what I want to do, with the, whatever it is, the actionable part. Does this make sense? Kind of. So, in thinking about architectural styles, these are the kind of ideas I want to see people take up. Maybe a functional approach to web design, and whether it's web server, web client. So going back to, this is where I want to have some discussion. So the Elixir formatter, when it came out in 1.6, I thought like, oh great, I spent all this time on the style guide, and now maybe half the rules are meaningless or no longer needed. A little bit of an existential crisis, but I thought, okay, maybe there's a way forward here with the formatter. Has anybody used the Elixir format? Yeah, you guys have used it. So I think it's pretty good. It's opinionated. You really can't configure it much. But for a style guide, I think it forces us to think more broadly about what the style guide can be about. So one possibility, one option is, let's just delete the style guide. This is one option we're considering. Another option would be, well, let's split the style guide into two parts. Let's have one part with all the rules the formatter can help us with, as a kind of like, good example of like good Elixir. And then let's have the second part of things where the formatter doesn't help us. So this is option 2. And option 3 is, do nothing about it. The Elixir Style Guide was the first Elixir project that I contributed to, and I became the maintainer. If anybody here wants to get into Elixir, I can highly please ask you to become a contributor. So with that, I'll go to questions.
Hi there. Hi, my name is Sonny. I had a question on the example that you had where you extracted the operation out. I was wondering, like, even in the previous example, you probably have something very similar if you would dig into the implementation of that get recent function, that it's using some underlying HTTP library. And it's probably going to prepare the package or payload pretty similar to what you have here in operation. There's something that's enough of the HTTP library to actually know what it needs to do, like know the verb, know the methods, know the HTTP headers. Where do you see the difference to that here?
Well, so there's actually an implementation that I did not talk about using protocols. So the request function actually dispatches it uses protocols to dispatch the correct module. So so protocols in Elixir are things like there's a protocol for converting something to a string. It's the string chars, right? Without that, it would be difficult or actually impossible to write a new data structure that can be converted to a string using the same function. So there's a kernel to string function that will match on the type, which actually even could be a struct, and will look for an implementation for that protocol. This works the same way. If you want to extend this, and the Flickr library doesn't really have to do this, but for AWS, there's like dozens of services. There's like S3, there's Dynamo. For them, when they add a new service, they don't have to change the core library. All they have to do is write the function that creates the operation for you, and then write the implementation of the protocol. And then you just use the same XAWS request function that you could use for any other request. So that's maybe to answer your question why this has an advantage. But yes, there is some similar code that would be there otherwise. Question up front?
Yeah, there's a library called Tesla, which takes a kind of a plug approach to making HTTP clients, which allows you to add in things like authentication as a header in a kind of a model.
Yeah, so library is Tesla that Jake mentioned. Yeah, it uses macros basically to define like you can put in what you want. It is kind of like a plug router in that sense. Yeah, so like there's this library Tesla which basically looks like plug router, functions in a similar way. That you can define change how the client behaves, sort of like changing how the router behaves.
Yeah, that's mostly useful if you have like a REST API that returns this kind of JSON for this thing and this other kind of JSON for this other thing, and you can just sort of make the parser be part of the changes.
Right. Any other questions in the back?
Not really a question, but regarding the get and whether or not the do should be there.
Oh yes.
I'm pretty sure it should be there. In general, in Ruby, when you define a method, you don't use do, but when you call a method, you do use do. Unless this is a special case that I don't know about.
I hope you're right. I think he's right. All right, extra points to the man in the back. Somebody's fact checked me. Thank you. Any other questions? All right. Well, I guess that's it. We have lunch at 1, or we have a break. Oh, wait. Before we go, I'd like to thank our moderator and our AV team for doing the hard work for this conference. Let's give them a round of applause.